Hey audience, this is Prajesh Chaudhary, Quantum Group. Let's see this very beautiful question of electromagnetic induction from Pathfinder. It's a build-up your understanding, question number 36. So the question states, the circuit shown consists of 4 capacitors, an ideal battery of electromotive force E, and an inductance, a switch and an inductance L. The capacitor of 3 of these capacitors is C and that of the 4th one is 3C. Find the maximum current through the coil, through the inductor after the switch is closed. Alright. So this is the situation in the beginning. These are the combination S1 and the switch S is open. So now for this combination, how much is the charge given by this battery, and before that what is the equivalent C of the system. So on this situation, let me say that this state is a state 1. For this state, equivalent capacitance is say C1. So C1, you can see that this is an open thing. There is nothing here because inductor is not connected. The C and C are in series, and this C and 3C are in series, and they in turn are parallel to each other. So for this, equivalent is C by 2. And for these two, equivalent is 3C by 4, and their overall equivalent would be C by 2 plus 3C by 4. So that would be C by 2 plus 3C by 4, and that would be 5C by 4. And now this is the final state. In this final state, this switch S is closed. And suppose this is a point A and this is a point B. So a current has started flowing. We have to find what is the maximum value of this current through the inductor. And when this current would be maximum, so obviously di by dt would be 0. Voltage across inductor is L di by dt. If di by dt is 0, so the voltage across inductor is 0. That also happens at the steady state. So when the current is maximum, there is no PD across inductor. VA is equal to VB, and VA is equal to VB means this situation is like this. So we will treat this as a conducting wire. So these two are in parallel, and these two are in parallel like this, and this combination are in series. So in this case, what with the equivalent capacitance? Suppose now the equivalent capacitance is, say, in this second situation is C2. So C2 would be, this is a 2C and this is a 4C. They are in parallel. So 2C and 4C in parallel. 2C and 4C are in series. So 2C into 4C upon 2C plus 4C, that would be 8C by 6. So we can write that will become 4C by 3. So according to this situation, how much the charge the battery has given to the circuit? The battery has given in this situation a total charge Q1 is equal to C1 into E. And in this situation, the battery has given a total charge according to the overall equivalent charge, that is C2. So C2 into E. So from here to here, how much the charge has flown through the battery? So obviously the charge flown through the battery would be delta Q would be Q2 minus Q1, that is a C2 minus C1 into E. And C2 minus C1 is, C2 is 4 by 3C, C1 is 5 by 4 into C, and that multiply by E. 16 minus 15 by 12, that is a CE by 12. So from here to here, from this state 1 to the state 2 when the current is maximum, how much is the work done by the battery? So work done by the battery is EMF into the total charge that has flown through the positive terminal. So E into delta Q. So that would be, just multiply this, that will be CE square by 12. And from this state to this state, state 1 to state 2, what is the change in the potential energy of the capacitor? That is a delta UC. So that would be, I can write the formula half CE square. So half C2 minus C1 into E square, and C2 minus C1, that is basically C by 12. So that will be CE square by 12. And how much is the change in potential energy of the inductor? Energy of inductor is when the current flows through it is I, that is a half Li square. Initially there was no current, and now we have to talk at the moment the state 2 is the moment when the current is maximum. Say that current is I max. So the change in potential energy of the inductor is half Li max square. So now we can apply the energy conservation the circuit. So energy conservation the circuit is WB is equal to delta U, change in potential energy, and there is nowhere the heat is being lost. So all the work done by the battery would be stored in the form of internal energy. And there are two types of internal energy, potential energy. One is the potential energy of the capacitor, and other is the potential energy of the inductor. So there are changes. So from here, work done by battery, we got the CE square by 12. Delta UC is 1 minute, if I calculate correctly, that will be the C2 minus C1 is C by 12, and there is 1 by 2. So that will become CE square by 24. So this is CE square by 24, and this is Li max square by 2. So from here we will get I max CE square by 12 by L will also come here, and we have to take the square root. Just simplify this thing, we'll get the answer. Thank you.